Hi everyone, and thanks for joining us today, and welcome to Day 4 of Innovator Island, where we're building a serverless web application for a theme park. So this is a live session, but everything today is recorded, and you'll receive links to these videos after the week is finished. So my name is James Bezic. I am a developer advocate for the AWS Serverless team, and I'm a self-confessed serverless geek. I've been working with serverless projects for 2 to 3 years, built some fairly large scalable applications. And prior to joining AWS, I was a software developer for quite a long time and also a product manager for quite a few years as well. So I've worked for lots of different startups as well as some large companies as well. And I have lots of interests, including theme parks, which is why I ended up building this application. One of the most important things on this slide is my email address and my Twitter handle. So if you have any questions at all during or after the presentation, send me your questions and I'll do my best to help. So today is day 4. We're almost through the day 5 days of the workshop. And what we're doing today continues to build on the previous 3 days. You can see the full five-day agenda in the corner there with that bit.ly link. So just a quick recap of what we've done so far. On Monday, we set up the Cloud9 IDE and then deployed a back-end and a front-end using Amplify Console to give you a public URL for your application. On day 2, we configured real-time messaging so we could get the ride times into the front end of the application so our park guests can see what the wait times are on rides. And then yesterday we did some photo compositing and saw how we could use chroma key and compositing using different runtimes to create an asynchronous background flow for when our visitors upload photos. And now today we're going to look at analyzing visitor stats for tens of thousands of park visitors. So the goal over these entire 5 days is to learn how to use a range of different AWS services to help you build applications for your own businesses and your own use cases. All of the code is provided for you, so you don't actually need to write any actual code to solve the challenges, just follow through with the instructions. And we have the whole team of DAs in the Q&A and serverless experts who are on hand to answer all your questions. So it's a great opportunity to answer any questions you have about this project or serverless in general. So good news, the park is now open. We opened this morning. There are thousands of people already here and business is booming. But the park management has questions about the numbers. We want to know what the visitors are thinking about the rides and where they're going and where they came from. So park visitors have wristbands that collect data during their visit. And the wristband records the entry and exit time from the park and keeps track of all the different rides that they've been going on. So our challenge today is to collect this data and find trends that can help answer business-related questions. Some of the tools we'll be looking at today include Kinesis Data Firehose. So that is what we can use to ingest the streaming data, and you'll be seeing how that works. Also, there's QuickSight, which is a business intelligence tool, which we'll talk about a little bit more. And then we'll be implementing a simulator to actually simulate all of this data that we're collecting. So mostly today we'll be going through the instructions and working with these tools, but I'll be breaking regularly for questions that you might have. So just a few prerequisites. So first you need an AWS account. If you don't have one, sign up at aws.amazon.com. Once you've logged into your AWS console, you need to select a region that's supported. These are listed in the GitHub repo and also shown on the screen here too. Once you've selected a region, please don't change that region during the duration of the workshop. Now we love to make announcements at AWS. My announcement today is we just added Dublin, so that if you're in that area, you can also now use EU West 1 for this workshop. Now, in terms of cost, this workshop is completely free for you to watch the videos. We're not charging anything for the training. But today you will incur a small charge for running some of these services. We're going to be playing with actually a fairly large amount of data. So just be aware that you will incur a small charge today. If you don't want to incur any charges, just watch me go through the exercises and see what I'm doing. And we've also added a cleanup section to the GitHub repo. So although I'll go through this at the end of day 5, if you end up dropping out of the workshop or you don't want to continue, please just make sure you go and look at the cleanup section, because it'll walk you through how to terminate all of the resources we've been deploying so that you don't incur any extra costs. To take part in today's activities, you'll need a laptop or a desktop computer, not a tablet. If you only have a tablet, I recommend you just watch the video and then go through the exercises later when you have access to a laptop or a desktop. Please use the Chrome and Firefox browsers for optimal compatibility. Most of what we're doing is through Cloud9 IDE, and we found it works best with those browsers. We'll be using a range of different serverless applications, so it's useful to have some experience with the AWS Management Console, but it's not essential. Now, everything we're doing today builds on previous days, so if you've not done anything before, just watch the video today and then follow on all the previous modules. Today we're going through Module 5. So we're on day 4 of this week's adventure, where every park guest has a wristband and it collects information about their visit to the park. We want to collect that information and run analytics on this. So we're going to see how we can collect that data and then analyze it with Amazon QuickSight. We have a number of important questions from our park bosses about the park performance and operations. So we're going to answer some of those today. So let's look at the services we're going to be using. Just do a quick recap of some of these. Cloud9 is our developer IDE, which you've been using every day. But on the back end, we've got a couple of new services. So you've been using AWS Lambda and Amazon S3, but the two new things are QuickSight and Kinesis Data Firehose. QuickSight is a business intelligence tool and visualization tool for large amounts of data. So it's really good for analyzing streaming data like this. And Kinesis Data Firehose lets us load in streaming data into data lakes, data stores, and other repositories for analytics. It's fully managed and serverless, and it scales automatically with no ongoing administration. So this lets us batch, compress, transform, and even encrypt data if we need to before loading it on into our next process. Now, the cost of this service is based upon volume ingested. There's no minimum fee or setup cost, but just be aware that the cost is related to the volume of the data that's going into this service. Now, it also lets you transform that data using Lambda as well. So if you need to take data in and do some work on it before it goes downstream to an analytics service, you can do that there too. So let's look at the process we'll be following today in just a little bit more detail. So we know we've got visitors' wristbands producing data. This produces a JSON payload that looks something like this. So in this payload, we've got a timestamp, we've got an event that happened, it tells you which ride the person went on, along with some other information about their name and their age and their birthday, and also where they visited from when they came to the park. It tells you the total number of rides they've been on so far as well. So as they go through the park doing things, we collect these sorts of JSON objects that are emitted to us. Now this then gets loaded into or ingested through Kinesis Data Firehose, which turns this into large objects at S3. So you'll notice as we do this, you start seeing 5 megabyte objects appear in S3. And these objects contain thousands and thousands of the underlying records. They're being batched together and stored as one object. Once we have these objects that start to arrive, that's when we turn on QuickSight. And so QuickSight lets us then build graphs and visualizations to answer these business-related answers. Now, in reality, one of the problems is we don't have a theme park or any real visitors, unfortunately. But instead, we do have a simulator. So this runs in a Lambda function, and that's what we're going to be deploying today to give you a sense of the amount of data that we could create in this system. So as usual, let's get started at this URL. This is the bit.ly link we'll be following, bit.ly/Innovator Island. But also paste this in the Q&A so I can switch back to my computer so you can follow along with what I'm doing. So first of all here, I'm going to just go to the bit.ly link and pull up our GitHub instructions. Now today we'll be working on Module 5, so we'll be going to that in just a moment. Before that, I want to show you what we've managed to build so far. So if I go back to my other screen, if we take a look at our theme park app, the latest one that we deployed, you'll find that it looks like this at this point. There's a couple of changes since we last saw it. So this has been running on my machine for a while, so you see all these ride times coming in there. So yesterday we deployed the photo processing piece. So I just wanted to show you that working. What you can do if you click on a ride, and then select Add New Photo, Add Ride Photo, and then upload your green screen image. What you'll see in the console, I pressed F12 to open up the console. is you can see the request that it made to get the pre-signed URL, and then you saw it uploading all of this binary data, this big blob of data. And at the very end there, once it's finished, we use the IoT topic to get the information back that the photo has been processed. So that's when this message comes back in terms of the message from IoT. And that's how we get this pop-up on the screen saying photo processed. So then when I go into the gallery, you'll see all of these photos I've been uploading, and that's just showing the photo once it's been composited and come back into the application. And so when you get this far, you'll see this new icon appears in the corner of the menu bar. Now yesterday we also had a challenge of running through module 4, which was the translation module. Now this is a fairly short module, but if you went through that, what you would have noticed when you deploy again through Amplify Console is there's another button that's appeared on the toolbar. And the point of this is to allow you to internationalize the application for visitors speaking different languages. So once you've run through module 4, you'll see this button appear. And if you click on this button, we can go from the default English into other languages like French. So if I pick now one of the rides, you'll see everything's coming through in French. Now I also set up 2 or 3 other languages, and you can select from dozens of languages here. That's Japanese, and this is Spanish. So that's what you would have seen if you completed Module 4 yesterday. So that's currently the state of the front-end application. Okay, so let's go back to Module 5 for doing today. What I'm going to do, if I log into my AWS console, this is my basic screen that I log into, and I've got my instructions on the right-hand side here. And we're going to go to Section 5, Park Stats. So today I'm going to run some of this side by side on the screen because a lot of it involves going through the console, so it might be a bit clearer following through the steps. So the intro here tells you some of the things that I just explained earlier, that essentially we're collecting this data through Kinesis Firehose, sending it to S3, and then we'll analyze this in QuickSight. So the first thing we want to do, if we go to our Cloud9 instance, you can get to that by going to the Services dropdown, just searching for Cloud9, and then it'll take you to your environments, and hopefully you've got the one from yesterday that you've been using. If you click on Open IDE, that'll start your environment. It might take a couple of minutes to start. I've already started mine, so I'll just go straight to that environment. Now, just like before, we want to first refresh all of the environment variables. These often get reset when you wait a day and the environment's been restarted, or if you start a new terminal. So I'm just going to paste this in here. So we've got our AWS region, account ID, and the deployment bucket variable is reset again. Now there's 3 steps here to running today. Firstly, we have to configure Kinesis Firehose. So let's start there. So I'll scroll down to the step-by-step instructions. The part above tells you more about the service and how it fits into this application. So first of all, I'll go back to the management console in step 1, click on Services, and then search for Kinesis. And once again, you want to make sure your region matches what you expect and what you've been using from previous days. You should see something that matches this image down here. So what we're going to do is click on Kinesis Data Firehose, and then click on Create Delivery Stream. That's our first stream. Normally you only see that splash screen if it's the first time you've used the service. So on step 3, I'm going to enter a delivery stream name of theme park streaming data. I'll copy this across and just paste it in here. Now we can leave all of these other defaults as they are. We're just going to use the default setup of this application, and then we're going to choose Next. So on the Process Records page in step 4, we're also going to leave all these defaults as they are and scroll down and click Next there as well. Now on step 5, on the Select a Destination page, in the Destinations section, we want to make sure that Amazon S3 is selected. It should already be selected for you. And then further down in the S3 Destination section here, where it says S3 bucket, we're going to click on Create a new bucket. Now for the bucket name, we're going to call this, as shown in step 6, Theme Park Data And because S3 bucket names need to have globally unique identifiers, we're going to put our AWS account number after that. Now, if you need to know what your account number is, you'll find that in the drop-down at the top. So what I can do here, if I just go back to my console, because we set up this environment variable, I can echo my account number. I've got it there. It's not essential to use your account number. It just really needs to be a random number. So if you don't want to use that, you can enter your phone number or something else. Well, I'll put that in there just to make sure that's unique to me. And then on step 6, I'll click on Create an S3 bucket. So that was the dialog box we saw previously. That looks about the same. So now back in this page that we had before, we're going to scroll down and click on Next. So on step 8, on the Configure Settings page, we're going to scroll down to the Permissions section, which is near the bottom, just here. And then we're going to click this button that says Create New or Choose. This will open up an IAM window. And what it does is basically pre-populating a role with all of the permissions needed, but it needs your permission. So what you have to do when this window pops up is just click on the Allow button in the bottom right-hand corner. Okay, so now that's done. On step 9, you'll see that in the Configure Settings page that the role name now appears in this permissions list. That's the one we just created. And then we just need to click Next. Okay, so that takes us to step 10. So this is the final review page. That's everything we need to do to set up our Data Firehose. So what we're going to do down here is we're just going to review all the settings to make sure they look like what's shown in the screenshot. In my case, it looks about the same. It looks exactly the same, actually. And then I'll click on Create Delivery Stream. So creating a delivery stream just takes about a minute. So we want to wait here for it to be created. And what you'll see is that this status becomes active when this is ready. So I'll take a quick break for everybody to catch up and look to see if we have any questions. I'll restart again once this delivery stream is active. So one of the questions was about the cost of using today's session. So in terms of the Kinesis delivery stream, let me just show you the pricing for this. So if I open up a new tab, if you look up any of our products, most of them at the top, you'll see a pricing section there. And so what you'll see here is it shows that for Kinesis Data Firehose, the cost is about 3 cents per gigabyte. Now, it varies by region. It varies between 3 to 4 cents, depending on where you are. So make sure your region drop-down reflects the area that you're running the service in. But you're looking at about 3 to 4 cents per gigabyte ingested into the service. Today, we expect to ingest somewhere between 5 to 6 gigabytes of data. Okay, so our delivery stream is now active. So what we can do now is continue on to the next step. So because we don't actually have a real theme park or any actual real guests, we've got a simulator instead. And what we're going to do here is deploy a simulator in a Lambda function. So I'm going to show you how to do that next. So down here in the How It Works section, this explains some of the things I talked about in the introduction. The most important thing is that we're going to be simulating between 70 and 80,000 guests going through the park over a 12-hour period. And the simulator is going to run this over a period of about 4 to 5 minutes. So we're really going to create quite a lot of data and throw this at the service. And so each guest is going to come into the park at different times of the day, go to different rides, and then rate different rides accordingly. So each time they create an event, we'll be getting a piece of JSON that was like the one shown in the deck earlier. It just looks like this, indicating what they're doing at that point in time in the park. So if I scroll down a little bit further to the part where we deploy the simulator application, let's start there. So I'm going to go to my Cloud9 IDE, just here. I'll clear the screen to make it a little bit clearer. I'll just close these as well. So the first thing we're going to do is cd into the directory that has the simulator code. And then you remember this from previous days. We're now going to do a SAM build, package, and deploy, because what we have there is a SAM build application. So as this deploys, I'll tell you a little bit more about the application. So first I'll run SAM build. And remember, SAM build executes the JSON, the package JSON file, and installs all of the modules needed for this application. SAM package takes the SAM template and bundles it into an install and uploads it into the S3 bucket we have for deployment. So that will then upload that to S3. That should be fairly quick. And the last command we'll be running is SAM deploy, which actually then turns that package into real infrastructure. So I'll just take that final command and copy that across. You'll see this is now starting to run. So let's take a look. I'll just come away from the instructions for a second and show you what this simulator actually does while it's deploying. So in that simulator function folder, I'll just open this up a bit, take it a bit bigger. You'll see in the theme park backend directory, down in part 5 park stats in the simulator, we get into this simulator function. There's an app.js file. And what this is simply just a Lambda handler that calls our simulator. So it's pretty straightforward. It's referencing this simulation.js code, which you'll also find in the same folder. Now in simulator.js, I'm using a number of different libraries here, but the important parts are that we've got some constants that are specifying how many people will allow into the park at any point in time, how many actions will allow per minute, and various other variables that are really the parameters of the simulation itself. This is something you can look at later, but it just simply simulates lots of people going through the park. The most important thing it does is in the lib folder, you'll see a dispatch.js. And in there, this is the part where as the simulation starts to build up events, it's batching those events and sending them off to Kinesis Data Firehose. So you'll see further down in this dispatch doc, that further down just here, there's one line where those batches get uploaded to Firehose. And these get uploaded in fairly large batches of 500 events at a time. So we're dealing with a fairly large amount of data here. So now this stack has now been deployed, what we'll do, I'll just close those windows and go back to the instructions. So now we're at the point now we're at step 4, where the stack has been deployed and we're going to start the simulation. So I'll just clear my console. Now you can run this from the Lambda console, but I wanted to show you how you can invoke Lambda functions directly from the CLI. It's often more convenient just to do it through code. So first let's get a list of our Lambda functions and just filter for that one that's been deployed. That's step 4. And that tells me my function name, which is right there. And then we're going to use this command AWS Lambda invoke. This takes the function name as a parameter. So I'm going to copy that. And I'll put in this Lambda function name. And then don't forget, just at the very end, output.txt. So any output from the Lambda function gets written to that file. So executing this will take 4 to 5 minutes. So once we get to this point, you won't expect the prompt to come back for a few minutes because now the simulation started. And what it's doing now is it's sending all of those events to Kinesis Data Firehose. So what we can do as this is running, if we continue a bit further down in the instructions, we can go to the S3 console and see the files starting to appear in S3. So I'll go back to my Kinesis tab that was open, and I'll click on the services drop-down and click on S3. Now here we've got lots of different buckets we've been creating throughout the day. And the one we want to look for is the one that begins with theme park-data. That's the one you created earlier. You should have your account number or phone number. And it was empty earlier, but you should find now it's showing that there's a directory in there, a folder. So I'll start clicking through these folders. And you'll see all of these objects starting to appear that are 5 megabytes each. Right now there's 14, but as I refresh, there's 16. And this number will start to grow. Now, when we configure Kinesis Data Firehose, we actually set how this batching operation works. We use the default settings earlier, which are 5 minutes or 5 megabytes. So basically, whichever limit is hit first, that's the point where it will write the batch to S3. But that's completely configurable depending on how you want your application to run. So I'll scroll down here. So this section, observing the output, essentially shows you this. It shows you within the S3 console, all of these objects are now starting to arrive. You see now we've got 28 objects. So down in next steps, we're going to wait here for a couple of minutes, just wait for this simulation to finish. And so when it does finish, we'll see a status code of 200 like you see in the screenshot on the right-hand side. And I'll just see if we've got any questions while we take a quick break. So a good question here, why do we need Kinesis? Well, Kinesis is really good for ingesting large amounts of streaming data. So in the real world, you think about things like IoT devices or even web applications, anything like mobile apps where they're emitting data constantly. You need an efficient way to pull that data together and ingest it. And normally in many applications, what you find is this data format is similar and you want to do something to aggregate or transform that data before you put it into a final data store for analytics. Now, it's absolutely possible to use things like API Gateway for this, but really a better choice of service for this is Kinesis. It's designed to pull in and aggregate this sort of data. So another question, how many objects in S3 are expected throughout this simulation? It actually varies because there's some randomness in the simulation itself, but typically we should end up with about 100 or so once it's finished. I'm at 57 so far. I've run it sometimes, it gets up to about 120. This seems to be about the maximum, but it does vary. Now, you can actually vary the simulation data. So if you wanted to run this and not produce quite so much data, what you could do inside the simulator function, if you look at the simulation code, just here in simulation.js, you could modify these variables to actually have a simulation that runs and produces a lot less data. So if you wanted to have maybe only 500 park visitors or reduce the number of actions per minute, this would make the simulation run a lot faster, produce a lot less data, and therefore would be cheaper to run. So Kinesis Data Firehose, one of the questions here, is effectively a serverless application because it's a managed service and it scales for us. So the beauty of this is that we only pay for the data ingested. And we don't have to deal with shards or any sort of administration or management of servers. We simply push the data to that service and it does the rest. So as we build our serverless web application, one of the big benefits is the amount of scale that this provides for us, so that as the number of users we have in the park starts to grow, everything works with us. The application on the front end scales, the middle tier that we've built, and all those Lambda functions, they scale automatically. And now in terms of ingesting this data from park guests, this also scales. So one person has found that they've only got 18 files after the simulation is finished. Yeah, there is some randomness in the way this works. So there's some variability in the number of guests that arrive and number of rides they take part of and how much they like your park. So you might find that you might have had a very quiet day at the park and it's not, as a result, you're not quite so much data as you expected. So mine is finished here. It looks like I've got a timeout in mine because I've got too many people in the park and I've exceeded my Lambda timeout, so I should have set a slightly higher timeout there. But I've got enough data to continue. So basically at this point, I've got all of these different S3 files that have been picked up and aggregated in Kinesis. So what I'll do now is I'll continue on with the QuickSight configuration in the next section, which is part 3 or part C of module 5. Now, setting up QuickSight, there's a bit of work in the UI we have to do here to make sure you put in the right settings things in the right places. So I'm going to walk you through this fairly slowly because it can be a little bit confusing the first time you use this. So in my services drop-down, I'm going to click this and click on QuickSight. Okay, so now we're on step 2 in these instructions. Now, the first time you ever use this, you'll see this prompt that the account has not been signed up for QuickSight, so you need to click the button that says Sign Up for QuickSight. Now, there are 2 different payment models for QuickSight. There's a standard version and an enterprise version. All we need for today is the standard version, so I'm going to select that. This all takes part in the free trial, so as long as we make sure that we terminate these resources at the end of the week, we won't be charged for our usage of QuickSight today. So now I'm going to select Continue. And that takes us to step 4 in this process. So we want to do several things here. We want to make sure that the region matches the region we've been using throughout the entire workshop. I've been in US East 1, so that's my region here. Yours might be different. And then for the QuickSight account name, we want to enter theme park admin followed by the account ID. So I'll do that. And again, you can get your account ID from a drop-down up here, for example. You'll see it just in the corner there. Or you could use the variable from Cloud9 to get your ID. So we set up a variable of account ID. And you can see the account ID there. Or you could just use a random number like a telephone number, anything that essentially randomizes your entry just here. Next, I'll enter my Amazon email address for my notifications. And then what we need to do here is uncheck any of the checkboxes. Make sure these are all unchecked. And then finally, we want to choose S3 buckets. Okay. So this gives us a pop-up of all the different S3 buckets in our account. So we want to look for that one we created for this purpose, this one beginning with theme park data with our account number. And we're going to check that box. You can obviously select all, but it's better just to give permission to these services for the buckets they need for the purposes that they're running. So we'll select the theme park data bucket there, and then click on Finish. So that's step 5. So by the time you finish with this, you should find that it looks like this. You've got your region selected, and you've got an account name that's unique to you with your email address. All of these boxes here should be unchecked, except for now you'll see S3 has been selected with one bucket selected, which was the one that you selected there. Now we'll click on Finish. QuickSight then creates the account, which takes just a few seconds, so we'll just wait for that to finish. While I'm waiting for that, I'll answer a couple of questions here. So one question is, what is the recommended timeout for the Lambda function for loading the simulation data? Great question. So Lambda functions have a maximum timeout of 15 minutes. This one has been set to 5 minutes, so it's actually possible for it to be a little bit too short. So I'd recommend setting it for 10 minutes just to make sure that it completely executes all the way through. Okay, now our QuickSight account has been created. So what I'm going to do here is, if you get any sort of splash screens like this, just click on Go to Amazon QuickSight. Sometimes when new features are released, you'll see a splash screen. So if you see one of those, just close that down as well. See, I've got a splash screen there, so I'll just close this. Now these are all just examples that are set up. We're not going to be using any of these, so don't worry about those. So first of all, we're going to click on Manage Data, which is in the top right-hand corner of the screen. Okay, now in step 2, I click on New Data Set. And then step 3, I'll select S3. Now step 4 is a little bit complex, so we'll walk through this fairly slowly. We have to provide a manifest file for it to have access to the S3 bucket and also know what the contents of the S3 bucket look like. So I created this JSON earlier, which shows you what the manifest should look like. So what we need to do is copy that JSON and open a file editor on your machine. I'm using Windows, so I'll just use Notepad. Any file editor will do. And I'll paste that JSON from step 4 into the editor. Now in the middle of the JSON, you'll see there's a part that says enter your bucket name. So we need to find the bucket name for this. So if I go back to the management console in S3, this is the bucket name we're referring to, the one that we created earlier, the theme park data one. Your number will be different, but it should begin with theme park data. So let's copy that value across to our clipboard. And then in the S3 section, we just paste that in there. Now we've got a manifest. So I'm going to save that to my local machine. I'll just put this in a temp directory. You could store it anywhere on your machine as long as you know where to find it. I'll save that there. Okay, so once you've finished, you should have a manifest that looks just like that on the right, but it now has your unique S3 bucket that you have in the manifest there. So back to this prompt that popped up, what we want to do first of all is give the data source a name. So we'll call it theme park data. And then on these radio buttons, select the upload radio button, and then click on the file icon, and select the manifest file that you just saved. I saved mine as in my temp directory. So we're just on step 5 now at this point. So we've entered theme park data for the data source name. We've selected the file that we created and uploaded it into the dialog box there. And now we're going to choose connect. Okay, once this happens now, just click on edit and preview data. You may get this error that says not enough spice capacity because with new accounts it hasn't correctly established your limits, but don't worry about that. Just click on edit and preview data. So I'll stop there just for a second because I know that there's a lot of different elements there to follow in the UI, and I'll just see if we've got any questions, and I'll restart in just a second. Oh, this is a good question. So what do the values signify in the manifest file? So you can specify different data types in the manifest file, such as JSON or CSV and a range of others. And you can also specify if the data contains headers or what the delimiter looks like. So there's lots of different things you can do with the manifest file. What does SPICE mean? Good question. Actually, it is an acronym. I forget what it is. It's essentially the data, the way the data is managed within the QuickSight service. I'm sure I can find the documentation. It's just an acronym, though. Okay, so next what we want to do is start preparing the data within the UI. So it's pulled in all of the different fields that we saw in the example JSON that we had earlier. We just want to change some of these data types, first of all, to make sure that they're correct. So what we can do is, if in step 1, if we hover over any of the fields, you'll see there's a little drop-down that appears here that lets us change these data types. So the first thing we want to do is modify the one that's called latitude, which is here. Click the drop-down, and I'll change the data type to latitude. This tells QuickSight that this piece of data is geospatial. It's not an integer or a piece of text. Now we also want to do the same thing with longitude, so we'll just click on that drop-down and change the data type there to longitude. And that completes step 2. And then the next one to change is the rating field. So you'll find that just down here. And we want to change this to an integer, so click on the drop-down, change data type, and we'll change this to an int. Great, so that shows you a preview of all the data just there. And now in step 4, we'd like to create a calculated field. These are fields where they are produced by looking at other pieces of data that were imported. So if I click on Add Calculated Field, what I want to do is, for the calculated field name, add minutes in park. And then for the formula, just use this formula here. It's just a date diff. It's like an Excel formula. And then I click on the Create button. And once you've done that, you'll see this new field that's appeared that is called Minutes in Park. And you should see that on the right-hand side as well there. So once we've finished with setting those data types and added the calculated field, we just click on the button that says Save and Visualize. Okay, so the data is now ready in QuickSight for us to perform some of the analysis. So we'll scroll a bit further down and look at the Create Analysis set. So first of all, we want to create a new analysis, which if you've got to this screen, just click on the New Analysis button. I'm already in that page, which is why it's not appeared. If you get prompted for creating a new analysis, just give that a name and it'll take you to this dashboard where you can then create analysis on this data. It'll look at like the screen I'm currently on. So in step 4, this just shows you what the various panels mean because we refer to them in the instructions. It's just worth knowing what these are. So on the left-hand side, you've got an analysis menu bar. And in this section here is the fields list. Then further down, there's the visualization types. These are different types of chart. Now, as we start to drag fields into this area over here, this section up here called field wells will give us options on what we can do with those particular variables. So what we're going to do is we've got 5 different visualizations we want to build here, and we'll do a couple of them together just to see how this works. So each one of these visualizations opens up a different page of instructions. I'll walk you through the first one, and I'll go fairly slowly so you can see where the different parts of the UI fit in. So in the first visualization, we want to know the average length of a park visit by age of visitor. So what we can do here is in the Add button at the top, just here at step 1, we click this, we click on Add Visual. And that then adds a new visual to the page. In step 2, we want to click on the filter icon and then click on Create One to create a new filter. In step 3, we want to select an event from the list. So we'll click this event. It's just loading those. Once that's loaded, I want to check on exit. I'm only interested in exit events to know how long somebody was in the park. So once I've clicked on exit, I'm then going to choose apply and then close. So that takes us to step 4 now in this list. So next I click on visualize back in the menu again. And I'm going to choose a horizontal bar chart, which is this option just on the second row. Now when you choose a chart, you'll see the field wells start to appear at the top, showing all the different possible values that it's expecting for this particular chart. So what we want to do is step 7 is drag the visitor age to the y-axis option just there. And in step 8, we want to drag minutes in park, which was our custom field we created. It's there. We're going to drag that to the value in the field well just there. Now, right now, this value is showing as a count of minutes in park. We want the average. So I'm going to click the drop down just here. I'm going to click on the aggregate option and change this here to average. Now finally what I can do is I want to change the title in step 10, so I'm going to copy that new title. If I scroll down to my visualization and click on the title, I'm going to replace that so we can see that we've got average length of park visit by age as our graph that's been created. Now if the simulator continued to create information, QuickSight will continue to receive this information on a fairly regular basis, and this chart would remain fairly up to date. Right now, our simulation stopped, so you'll find this data just stays the same as it is. I'll stop here for just a second, because I know working through these UIs can be a little bit tricky the first time, and I'll just see if we've got any questions. So one of the questions about having a completely different UI compared to the one in the docs. As Chris said, it's possible if you choose the enterprise option versus the standard option, you'll see more features available. It has more bells and whistles that we don't use for this, but you can still go through and use that version to complete many of the steps here. One question from somebody saying they cannot convert the data types. So let me just go back a step to show you that. It's important that you're in the data types page to be able to do that. So the best way to get to that, if you click on the icon in the top corner, that takes you to, I'll just close this what's new option there. It takes you to the home screen of QuickSight. In the top right of there, you'll see a button that says Manage Data. If you just click on that, and then you'll see various samples here, but the one we want to select is theme park data. So if you click on that option, then you want to select Edit Dataset, the button just on the screen in the bottom left of the pop-up. Now once it's loaded the fields, that's when you see this drop-down where you can change these data types. If you select a field, you can change these data types. But it's only when you're in the mode of editing data that you'll ever see this drop-down appear. From the standard screen, that doesn't appear. So I'll go back to our analysis page that we were on so we can build the next one. So let's do the next visualization. I'll just go back to the previous instructions that showed our list of 5 visualizations here. Let's do number 2, which is where are the visitors from? So I'll click on the go to instructions there and scroll down so you can see I think there's 10 instructions here. We have about 8 we have to follow. So this is very similar to the steps we followed last time, but I'll go through these again so you get to see how this works in the UI. So first of all, click on Add in the top menu bar, and then choose Add Visual. That's step 1. That opens up a new visual just down here. In step 2, you want to click Filter on the left-hand side in the Analysis menu, and then click on Create One. And then we want to choose Event from this list here. And I'll just click it to open up. It shows you all the pre-selected values that are available. So in step 3, I want to choose Entry. This is what the event type I'm interested in for this particular analysis. I'll click on Apply and then Close. Great, so on step 4, now we want to click on Visualize. And we want to choose Points on Map. So we'll look down the visualizations here and find the one that's called Points on Map. It looks like a little globe, so I'll check that. Now remember, when you select a visualization, the field wells update to show you the values that it's expecting. So what we're going to do is we're going to drag our 2 geospatial pieces of data at the same time, latitude and longitude. So I'm going to select both of these, and they'll automatically appear in the geospatial dropdown because it's detected the data type of those fields. And then if I select the title of the visualization, I want to change it to where the visitors are from. And let's change the title there. And I'll make this a bit bigger so you can see. This now shows me drop pins of where everybody is from in my park. Looks like we've got a lot of people from Texas today. So that is the second visualization. And as you build these visualizations, what you'll see is you can start to build dashboards when you go back to the analysis. I'll just click on the analysis page, where each of these ones you're building, you can put them together and create a dashboard that you could share with other people to answer these business questions. I'll just switch across to see if anybody has any questions at this point. So if you get stuck following these, just remember the different parts or different panels that we're in here, because when you filter an event, that's a filter panel just here. Once you've created a filter, you then want to switch back to Visualize, which is a separate menu item there. So these are modal. You want to switch between the 2 of these. So somebody asked why their latitude and longitude would be showing up in the wrong field well. It's possible if you skip the step where you convert the data type to a latitude or a longitude, if it's picking it up as an integer or as a string, it may not detect that. So go back a little further in the instructions to the part where you modify that data type. I'll just show you where that is. If we go to the quick site, it's when we initially set up the data. I'll just make this a bit bigger so you can see. A bit further down here. This is where we were preparing the data. So just go through the preparing the data stage to make sure that your latitude and longitude have been set as those data types in the instructions. I think we've got time for one more visualization. So what I'll do is I'll show you the next one. I want to do ride rating by popularity number 4. I'll skip number 3 so you can try that separately. So I'll click on Go to Instructions. This is ride rating by popularity. So these instructions, again, they're very similar to each other. So I'll step through these so you can see where I'm going in the UI. In step 1, the first thing you do is click on Add, and then click on Add Visual. And in step 2, you want to filter in the analysis bar. You'll see there's nothing there currently, so click on Create One. In step 3, choose event from the list. And this time we're going to filter on, I'll just click on Include, I'll filter on rides as an event there. So I'll select ride, and then click on Apply, and then just close to close this dialog. Now in step 4, I'm going to click on Visualize, and I want to create a tree map this time. So what I'm going to do is look down the list of different visualization types until I see a tree map. And you'll see this one, it looks like a heat map with different squares. So I'll select that one. Again, the field wells, when it knows what type of visualization you want to create, they automatically choose the appropriate types of field that you need to provide for the data in the map. So in step 7 now, I'm going to drag ride ID from there to the group by box. So we're going to group by ride. And then in step 8, I'm going to drag visitor ID to the size box. And then finally, I want to drag the rating that the visitor provided for their ride experience, into the color box. And we want to then finally, on step 10, click the drop-down arrow next to the rating field. And we want this to be an average instead of a sum. So when I hover over the aggregate submenu, I can change this to average. If I scroll down, because the visualization appears at the end, I then want to change the title again. So I just highlight the new title, click on this title, and paste that in there. So ride title by popularity. So now I'll just make this larger so you can see this. You can see what we've done is we've created a heat map of the rides that had the most with most number of visitors, but also the popularity of that ride. So this one, ride number 5, only has an average of 3, whereas ride number 9 has an average of 4. And that's how you can easily visualize the number of rides and number of riders and what they thought of the ride. So what I'm going to do is I'll leave the other visualizations for you to finish, and I'll just go back to the deck just to wrap up a couple of things and introduce you to the bonus challenges in this section. So you've got a couple of other visualizations to try there. I did 1, 2, and 4, but you can do 3 and 5. It should just take a few minutes to run through. But here's some really interesting questions you can go through with the data that the simulator's provided. So the first question is free on your birthday. So park management is considering offering free entrance to anyone on their birthday. So tickets are currently $89 a day. So create a visualization that shows how many visitors today celebrated their birthday and what the total cost of the program would be based upon today's attendance. The second challenge is about staffing the turnstiles. So park management is looking to optimize staffing at the park entrance. We have 100 turnstiles, and each is capable of processing 10 visitor wristbands per minute. And one staff member can process 2 turnstiles. So produce a visualization there showing the number of visitor arrivals throughout the day by minute and make a recommendation for turnstile staffing throughout the day. And the final challenge is finding out which rides are not performing. Now, you may have noticed when you look at the real-time data coming into the park that quite a few rides seem to be broken down fairly frequently. So see what you can find out here, because park management is concerned that some of the rides are not that popular with visitors. And so create a visualization that shows the 3 least popular rides. So all of this is available if you go to the bit.ly link of Innovator Island and select the Module 5 challenges that we were on. If you scroll down to the bottom, you'll see these advanced challenges with a lot of additional details about what you need to know. It also provides links to some of the documentation to show you some of the more advanced features of QuickSight. So that concludes today's activity. So what have we done today? We've configured QuickSight, Kinesis Data Firehose so that you can ingest streaming data into the back end of our system. We then set up and configured a simulator so that you can produce large amounts of data to simulate what would happen if we had lots of people coming into a park producing this sort of data. And then finally, we set up QuickSight and started creating some of the visualizations to visualize this data. And QuickSight plugs into our S3 bucket where all the data has been aggregated by Kinesis. So at the end of today, don't close down any of your Cloud9 instances or terminate them. You can close the window, just let them go into standby. So tomorrow, when we start again, they're ready again. And don't delete any of the resources that we have created throughout the workshop because we'll be using those tomorrow. In the meantime, if you have any questions before tomorrow, feel free to reach out to me with any questions you like. I've spoken to lots of you so far. Don't be shy to send me a question if something doesn't make sense or you're having any sort of trouble. You can send me an email to jbezic@amazon.com or reach out to me on Twitter at this Twitter handle here. Otherwise, thanks very much for your time. It's truly a pleasure to talk to everybody like this and share my theme park vision with the world. So I hope to see you tomorrow. Thanks very much, and I'll see you then.